We will continue to explore the temperature-dependent sex determination with how to estimate the TSP, the thermosensitive period of development for sex determination. First, let's do a summary of what we have seen previously. First, we saw that we can model the development of embryo using two different kinds of model. One, Gompertz model using the straight carapace length as a proxy of the metric, and another model, a linear model, that models the progression of development from 0 to 1. Here you see a table of development for careta from the thesis of Jakub Kaska. The stages are numbered by the system of Miller, published in 1985. You have the straight carapace length measurement and its standard deviation, and the number of days since the beginning of the incubation. This graph at the right is a graphical representation of this data with the stages which are presented and the Gompertz model of growth fitted using a bivariate Gaussian distribution. We have saw also in the previous video that the sex is sensitive to incubation temperature during a period of development. This period is named the thermosensitive period of development for sex determination. This period has been determined in different species. Here, this is the work of Claude Piot and Mireille Dorizzi in Emys orbicularis, and it was based on the shift during incubation from feminizing temperature to masculinizing temperature. They show that the thermosensitive period of development for sex determination was from stage 16 to stage 22, based on the numbering of intima published in 1968. Then we should convert the intima system into Miller system. This has been done in the work of Sabine Renou, published in 1989, and you have a table of correspondence between Miller stages and intimate stages. Then, taking into account that Piot and Dorizzi have determined that TSP was located between stages 16 and 22 in intima stages system, we can see that it corresponds to the stages 23 to 27 in Miller stages. We have positioned the thermosensitive period in the graph, and then we can see that these stages of beginning and end of TSP correspond to certain size in careta embryo. Now that we have determined what are the embryonic size of embryos that permit to delimitate TSP, we can here make the model of growth of embryo within a natural nest with green temperatures, and you see that the TSP is completely shifted at the right of the development in this Gompertz model. If you compare the average temperature within the middle third of incubation and the TSP determined by this method, you can see that there is a bias. The average temperature in the middle third of incubation is nearly 1 degree Celsius lower than the true value during the TSP. Now let's see what's happened for the model of progression of growth, the linear model. The thermosensitive period is located from stage 23 to 27 for Miller, but here we don't know where are the stages. We can see that, as a rule of thumb, the TSP is located at the second third of incubation, when incubation is done at constant temperature. As the model is linear, if you are at the second third of incubation duration, you are at the second third of progression of development, then from dot 33 to dot 66. Now let's do with a natural nest, the same nest as previously worked for Gompertz model. You can see that the TSP is also shifted to the right as compared to the second third of incubation. And if you compare the Gompertz model and the linear model, you see that in both cases, the TSP is shifted to the right. This is normal because you have a trend of incubation temperature, positive trend. But the TSP is more shifted in the Gompertz model than in the linear model. And note that this is true only because we are at fluctuating temperature. At constant temperature, we will not see this. Now let's compare the TSP position in linear and Gompertz TSP. At the top left, you have the beginning of the TSP. It is later for Gompertz model than for linear model. The end of TSP is also later for Gompertz model than for linear model. But you see at the bottom that the length of the TSP is higher for Gompertz model than for linear model. If you compare the average incubation temperature during the TSP for Gompertz versus linear model, you see that you have a strong bias of minus 7 degrees Celsius. The average temperature in the Gompertz model is higher than the average Gompertz for the linear model. So both models are not equivalent in terms of TSP measurement. So the TSP can be located using the size of embryo stages as guide for Gompertz model and as the middle third of progress of development rule of thumb for linear model of development. The middle third of incubation is never the TSP except for special case of constant incubation temperature. It's used to produce a bias estimation of the average temperature. So never use the middle third of incubation as a proxy of TSP. The exact position of TSP varies between Gompertz and linear model, and it changes the average temperature that we can estimate within the TSP. So in conclusion, as the Gompertz model has a more direct interpretation of TSP, we consider that this is the best method to estimate the position of TSP, and this is the method we will use later. Thanks.